Hey folks, in this lesson we are going to talk about transformations, specifically reflections and some review of translations. For your warm-up, I will give you a bonus 5 points if you go on to Schoology and message me one positive thing that's going on in your life. Could be big, could be small, anything positive. Tell me something good. Before we get into reflections, I want to go back and revisit translations. Translations are a type of transformation, one that moves or slides our function around. Doesn't change the shape, just changes where it's located. One of the things we've looked at that will help us with these transformations is this phrase high-vo. High-vo seems silly, but it is super helpful in recognizing that all horizontal transformations are going to show up on the inside of our function. All vertical transformations are going to show up on the outside of our function. Now, translations or movements, these showed up in our equations as addition or subtraction. So we're either going to add or subtract some number. Depending on if that number is inside, outside, positive or negative, that would change the direction that we're working in. For the horizontal transformations, if I have x plus some number on the inside of my function, like x plus 3 on the inside of a quadratic, x squared, this is going to move my function to the left. If I have x minus 3 on the inside of my function, like on the inside of this quadratic, that's going to move it to the right. Horizontal transformations are always opposite of what you expect. Vertical transformations are going to follow what we expect. So if I have a positive plus 2 on the outside of my function, it's vertical, it's going to move it up. If I have a negative 2 or a minus 2 on the outside of my function, that's going to move my function down. So what I'd like you to do is take a look at these two. You have a transformed quadratic on the left and a transformed square root function on the right. Pause the video, give these two a try. You are going to describe the transformations in each and then draw a quick sketch of what you think the graph would look like. All right, so if we look at this first equation here, we have two transformations happening. This minus 3 on the inside is going to move our function to the right 3 units. The minus 6 is going to move our function down 6 units. So the graph of that function is the same shape as the original, a quadratic, y equals x squared, that's been moved to the right and down. For the second equation here, we have the square root function. The plus 5 on the inside is going to move our graph left 5 units. This plus 1 on the outside is going to move our graph up 1. So our square root function stays the same shape. It still has that arrow, but now it's been moved to the left and up. So our ultimate goal in Unit 5 is to be able to transform parent functions into things that can model real stuff. If I take a look at my parent function, y equals x squared, that's my quadratic that has the shape of a parabola. This shape can be transformed to model things like the path of a baseball when a home run is hit, or an arch like in the Eiffel Tower, or maybe a nice curve within a roller coaster. In order to be able to model those different curves, I have to be able to change the way this parent function looks. And just being able to move it around, left, right, up, and down, isn't quite enough. So we're today going to add to our transformations, and we're going to take a look at reflections. So what I'd like you to do is take a look at how these equations can flip our functions. There's two different directions our functions could flip or reflect. They could reflect up and down, vertically, or they could reflect horizontally, left and right. So let's experiment and look at how we can modify the equations and their graphs to make this happen. So what I'd like you to do is open the Desmos app, or in a browser, you can head to desmos.com/calculator, and I want you to type in these four equations. See what happens with their graphs, compare them, see if you can notice any patterns. Pause the video, head to desmos.com/calculator, or use your Desmos app to graph these four equations. See what happens. All right, here's what you should have found. In our original parent function, y equals the square root of x, we have our original arrow, our original square root function. When I add a negative to the outside of that function, multiplying our function by -1, my arrow flips upside down. Okay, it's been reflected vertically. When I add a negative to the inside of that function, my graph has been reflected left and right. It's been reflected over the y-axis, meaning it's been reflected horizontally. The last one has a negative on the inside and on the outside of the function, which means there's two different transformations happening. Our transformations are both horizontal and vertical. The negative on the outside is going to reflect vertically. The negative on the inside is going to reflect horizontally. So we have both a vertical and a horizontal reflection happening. Now I want you to take a look at your next parent function, your quadratic, y equals x squared. In Desmos, take a look at these two equations. When you put a negative on the inside or the outside of your function, what happens to your graph? Are you noticing any patterns? Pause the video, check out these graphs, see what you notice. All right, in our original parent function, y equals x squared, we get a nice parabola shape, the U shape. When I add the negative to the outside of the function, the parabola has now been flipped upside down. So flipping it vertically, we would call this a vertical reflection. When I add this negative onto the inside, multiplying it by -1 inside of the function, I flip it horizontally. However, the graph looks exactly the same, and this is because the original graph is symmetrical. So there is a horizontal reflection happening. It's just that the end result doesn't look any different. All right, last parent function to analyze, the absolute value function. Try this one. What's going to happen to this absolute value function if you multiply by a negative on the outside and on the inside? How would you describe that? And what does the graph look like? All right, taking a look at our parent function, the absolute value function, we have a V shape. Multiplying by a negative on the outside is going to flip that V upside down. Vertical reflection, flipping it upside down. Putting that negative on the inside doesn't look like anything is happening, but in fact there is a horizontal reflection. It's just that the original graph is symmetrical about the y-axis, so we don't notice any change to the resulting graph, even though there is a horizontal reflection occurring. So depending on our parent function, we may not be able to rely on the graph to know what's happening. We have to also look at the equation. So a transformation is just a generic term referring to any sort of change in a function's graph, any change in size or position. Translation is the first type of transformation that we looked at. This is a slide or a movement into a new position. So that's moving a function either up, down, left, and or right, depending on what is happening in the function's equation. Okay, we also know that this looks like an addition or a subtraction inside of the equation. The second type of transformation is the reflection. So a reflection is a flip over a mirror line. That flip can either happen vertically, upside down, or it can happen horizontally, left and right. What that looks like inside of the equation is a multiplication by negative. All types of transformations have consistency in high VO, that any horizontal transformation is going to show up inside of the function, regardless of whether it's a translation or a reflection. Every vertical transformation is going to show up on the outside, regardless of the type, whether it's a reflection or a translation. So if I first look at translations, inside versus outside will tell me horizontal versus vertical. I can go one step further to look at the direction. So if my function, for example, was y equals x squared, a translation inside of the function is either going to be left or right, horizontal, inside. If I am adding inside of the function, like if I have x plus 2 squared, this is going to move my function to the left. If I'm subtracting on the inside, like x minus 3 squared, this is going to move my function to the right. Vertical transformations happening outside, this is going to be a movement up or down. If I have an addition on the outside, this is going to move my function up. If I have a subtraction on the outside, this is going to move my function down. With translations, we want to be more specific than just horizontal and vertical. We want to be specific about the direction. With reflections, we can't be any more specific than just horizontal and vertical. Reflections, instead of add or subtract, are going to show up in our equation as a multiplication by -1. So if I take that same parent function, y equals x squared, a -1 on the inside would look like this. That negative directly impacting x inside of that power of 2. This would be described as a horizontal reflection. The only other thing we can specify about this is that that horizontal reflection, which is left and right, would be over the y-axis. If that negative is on the outside, it would look like this. It's going to come in front. That multiply coefficient is going to happen first, negative x squared. This is going to be a vertical reflection. The vertical reflection is going to be up and down. This is going to happen over the x-axis. All right, so now it's time to put it all together. The first thing that we want to be able to do is describe any sort of transformation that we see from a function's equation. So I'm going to take a look at the first one with you together, and then I'm going to ask you to try the second and third function descriptions on your own. So the first thing that I do when I look at a function is to determine what was the parent function. So if I look at this first one here, I see a square root within there. So I know that my original function, my parent function, was a square root of x. The next thing that I'm going to do is think about what changed from the original parent function into the one that's written here. The first thing I notice is that the x has been multiplied by -1. I also notice that a -10 has been written after the square root. So as I analyze these, I'm going to think about where is that transformation and what type of transformation is it. So first, I see this multiplication by a -1, and I notice that it's on the inside of that function. So since it's on the inside, I know it's going to be horizontal. Since I'm multiplying by a negative, I know that this is a horizontal reflection. So I'm going to describe this as a horizontal reflection that's going to go over the y-axis. The second transformation here is on the outside. So I know this is going to be a vertical transformation. It's not a reflection because I'm not multiplying by a -1. It has to be a translation since I'm adding or subtracting. So my options are translation up or translation down since this is vertical. Because I'm subtracting 10, I know that this is a translation or movement down. So I'm going to describe this as a translation down 10 units. Doesn't need to be complete sentences, just enough of a description to get a good idea of what's happening to that function. I'd like you to pause the video and try the next two on your own, identifying all of the transformations you see, trying to be as specific as possible. All right, compare your answers and see how you did. In the second one, we should have two different transformations. The first one, horizontal on the inside, is a translation to the left 2 units. Be careful, opposite of what you would expect. This is moving to the left. On the outside here, this negative is going to be a vertical reflection over the x-axis. Multiplying it by -1 is always a reflection. In the next scenario, we actually have 3 different transformations happening. The first one here, I always like to start on the inside, is a -3 on the inside, which is going to move our function to the right 3 units. Next, we have this vertical transformation of multiplying by a -1. Vertical outside means it's going to be a vertical reflection over the x-axis. This +5 is also outside, so we have a second vertical transformation. This +5 is going to move our function up 5 units. We also want to be able to go in the reverse direction. So given a description, I want to be able to write an equation that would model that transformation of the function. So first one I'm going to do with you. I'm going to ask you to try the second and third on your own. The first thing that I'm going to look at is what function am I given to work with. So I see here my parent function is the absolute value of x. Next, I'm going to look at the types of transformations that are happening, and I'm going to start thinking about where is that going to show up in my function. Is it going to be on the inside or is it going to be on the outside? So the first transformation I see here is a movement to the left 4. I know that that's going to be horizontal, so it's going to show up on the inside. I also know that the left movement is going to be an addition. So on the inside of those absolute values, I'm going to have x plus 4. Next up, I have this movement up 5. I know that's a vertical movement, so that needs to show up on the outside of my function. Moving up is a translation, so that's going to be addition or subtraction. Since I'm moving up, it's going to be addition. So my full equation here is the absolute value of x plus 4 plus 5 on the outside. I'd like you to pause this video and try the next two. What transformations are happening in each function, and what does that look like as an equation? All right, go ahead and check your answers. In number 2, we have 2 different transformations that are happening, but they're both vertical. So they're both going to show up outside of our function, outside of the square root. This movement up 7 is going to show up as a +7 tacked on to the end on the right side. The vertical reflection is going to be a multiplication by a negative. That's going to show up first. That coefficient of -1 is going to be out front to the left. Still outside, just on the opposite side. In number 3, we have 2 different transformations. One is horizontal, one is vertical. The vertical transformation down 2 is going to be a -2 on the outside. The horizontal reflection, the multiplication by -1, is going to be on the inside of our function, which is going to be within that base, underneath the power of 2.